Okay, we're going to continue with this 6 weeks 3 review. We're on lesson 2, 7.7a. It says for us to represent the following phrases with a mathematical expression. 3 units, more than the width. Well, more than means that we're going to add, so we're just going to put the 3. Add the width, we're going to put W for the width. 14 units, less than length. And remember, when it says less than, we got to flip that over to the right side, so less than 14, or 14 units less than the length. We're going to put an L, and I kind of make it look like a cursive L so that you don't confuse it with a 1. The next one, 5 times as much money. 5 times, that means multiply. Money, we're going to call that M. So 5 times M. 1/4 of the perimeter. Of means multiply. So 1/4 of the perimeter, P. Remember, when you have a number right beside a variable, that coefficient of the variable, that's the words, means that you have to multiply this times P. Of always means multiply. Okay? Alright. The second question. It wants us to complete the table below so that it represents the equation 3x plus 2. So we've got these 4 values of x, and we're going to substitute them into this equation, and we're going to figure out what our corresponding values of the y would be. So 3 times, instead of x, -3 plus 2. 3 times -3 is -9, plus 2 gives me -7. And that's what y is, equals y, -7. 3 times 6 plus 2, that would be 18, plus 2 is 20. 3 times 9 plus 2, 3 times 9 is 27. Add 2, you get 29. The next one, 3 times 12 is 36. Plus 2 is 38. So those all gave us y. All we did was substitute in these values of x into this equation, and it gave us what y is. You see? Okay. Moving on. On the back side of that, number 3, it tells us to complete the table below so that it represents the verbal description. So it says the longest side of a triangle y is, or equals, 6.5 units longer than the shortest side x. Longer than means plus. Okay? And because we need things in this format, y equals mx plus b, we're going to put the x on this side, and y is equal to x plus 6.5. We're just keeping it in that format and getting used to using that. Okay? So if that is our equation, y equals x plus 6.5, then we would add 4 to it, and that gives y as 10.5. And this x is 5 plus 6.5 means that this y is 11.5. And this x is 8 plus 6.5 means that y is 14.5. And this x is 11 plus 6.5 gives me 17.5. Okay, so we filled in everything. Number 4, write a verbal description that represents the linear relationship shown in the equation below. X represents the number of sports cards that Jonas has, and Y represents the number of sport cards that Brent has. Okay, so we're going to say Brent has two less than, that's from this right here, 4 times the number of cards that Jonas has. So if Jonas has 1, 4 times 1 is 4, minus 2 means that Brent has 2. Okay? Again, we're going to start off with Brent has, and that has is the equal sign. The plus 8 is 8 more. Than 1/2 of the number. X is the number that Brent has, right? Or the number that Jonas has. Brent's. What is that? Brent. Half of the number of cards Jonas has. Okay? Alright. Number 5. Write the equation and verbal description that represents the linear relationship shown in the table below. X represents the height of the triangle, and Y represents the base of a triangle. Okay? X is the height of the triangle. Y is the base of the triangle. Okay? Alright. So what we're going to do is we're going to find the change in Y and the change in X. Remember, that's my rate of change. And earlier I told you that we are going to get used to using this format. Y is equal to mx plus b. And that's because that's what we're going to be using to solve these types of equations. And right now we're still just writing those equations. So what is the rate of change? Well, in this formula, it's that right there, that m. Remember that? Okay. Change in Y, change in X. Our change in Y from 7 to 9 is a change of plus 2. Our change in X from 3 to 4 is a change of 1. If I go from my first number to my very last number, you can use any of the numbers here and get their differences. From 7 to 25, that's 18. From 3 to 12, that is 9. Notice that those two are equal, and they should stay equal. That rate of change needs to be consistent. Okay? 2 divided by 1 is 2. 18 divided by 9 is 2. My m in this case is 2. So, if y is equal to 2 times x plus a number, let's figure out what that number would be. So, let's use this ordered pair 3, 7. If you use the ordered pair 3, 7, and you plug them in, remember this is x and this is y, 3 into here and 7 into here, then we can figure out what b is. Okay, we're going to say 7 equals 2 times 3 plus what number? 1. So now we have the formula that will work for any of these, not the formula, the equation. So y equal 2 times x plus 1. And let's see if this works for all of them. 2 times 3 plus 1. 6 plus 1 is 7. Yes, it works. 2 times 4 plus 1. 8 plus 1. It works. 2 times 6 plus 1 is 13. It checks. 2 times 12 plus 1. It checks. Okay, we did good. So let's see if we can get through another lesson without any interruptions. The first question tells us to write 3 formulas that can be used for working problems with circles. So I'm going to write a, let's see. First of all, let's start off with the relationships between the diameter of a circle and the radius of a circle. The diameter is equal to 2 times the radius. Okay, that's the most simple formula. And maybe I'll draw you a picture in a second. And then the second one, getting a little more complicated, the circumference of the circle is equal to pi times the diameter. And then the last one, area of a circle is equal to pi times the radius squared. Okay? So just to remind you all of the different parts of the circle, we've got my circle. I'm going to label the radius. This is the distance halfway across. If I double that radius, the distance all the way across the circle is the diameter. So that's where this comes from. Diameter is equal to 2 times the radius. And then the circumference, that's the distance around this circle. If you multiply this diameter times pi, which is 3.14, or approximately 3.14, then you will get the circumference of the circle, the distance around it. Okay? And then the area of the circle, I take the whole area of the circle, okay, and I square the radius, and then I multiply it times approximately 3.14, then that will give you the whole area of this circle. Okay? Don't get that vocabulary confused. You got to remember radius, diameter, circumference. All right. Number 2, it tells you to find the circumference and the area of a circle with a given diameter. Okay? So it told us this is the diameter. This is the diameter. It wants us to find the circumference, and it wants us to find the area. So I'll write it out. Remember, circumference is equal to pi times the diameter. Area is equal to pi times the radius squared. Okay? So, if the diameter is 10, we need to realize that the radius is 5. The radius is half of the diameter. If the diameter is 24, the radius is 12. And we use diameter for the circumference formula, but we use radius for the area formula. So we need both of those. Alright, it says to find them in terms of pi and approximated to the nearest hundredth if needed. Okay, so we're going to find it with pi, and we're going to find it with 3.14. And it wants us to do that with both of them. Pi, 3.14. Okay, it's easier for us when it tells tells us to just leave it in terms of pi, because then you don't really have to do anything. All you have to do in this case, you leave pi alone and you put the 10 for the diameter. So we say circumference is equal to 10 times pi. And then over here, circumference is equal to 10 times 3.14. We have to actually multiply that out, and when you multiply times 10, that's just bumping that decimal over 1. So circumference is 31.4. Okay? And there's not really any units here other than just the word units, so we just put units. Area, we're going to do it in terms of pi. So we've got pi r squared, so pi stays by itself, and we're going to take the radius, which is 5, and square it. 5 squared is 25, so there the circumference is 25 pi. Okay? So I guess I forgot to do the bottom one over there. Oop, didn't leave myself any room to work. Yeah. And then here, circumference is equal to 25, as we already figured that out, times 3.14. If you multiply that out, 25, I'm going to put 3.14 on top. 5 times 4 is 20, 7, 15, 0 placeholder. 8 and 7 is 15, 1, 8. And then bump the decimal 2 places. So the circumference is 78.5. Okay? And this is area, so this is square units and square units. Okay? These are the same thing, guys, except for this one is just approximated. We use the 3.14 instead of just leaving it in terms of pi. These are the same number, okay? Same thing over here. These are the same number. All right. Let's do the one that I overlooked over here. We're going to use 24 for the diameter and pi for the circumference. So this one, the circumference is equal to, put 24 first instead of the pi first, because that's how it's usually written, with the number before pi, and that is 24. I know it looks wonky, but that's what it is. And then over here, we're going to use circumference is equal to 24 times 3.14. I'm going to let y'all multiply that out and get the answer. And then this one, not circumference anymore, we're looking at area now. Area is equal to the radius squared, 12 squared times pi. 12 squared times pi. So the area is equal to 144, because 12 squared is 12 times 12. 12 times 12. And there we go. So 144 pi. And then this one, come over here and take 144 and multiply it times 3.14 and get your answer. Put it into your calculator if you have one and work it out, or use the calculator that you were born with. Okay? Alright, number 3. Determine what positive number was squared to give the value below. So 5 is the square of what number? 25. Did I say 5? Because I was answering the question. Yeah. So if we square 5, we get 25, because 5 times 5 is 25. 81, well, 9 times 9 is 81. 16, 4 times 4 is 16. So that's what it's talking about when it says it is the square of. Think about it as this square. 4 times 4. 16 is the square of 4 times 4. Okay? Number 4, the area of a circle is 100 pi square inches. What is the radius of the circle? So if area is equal to pi r squared, and this tells us that the area is 100 pi, then we know that the radius squared is 100. So if the radius squared is 100, then the radius times the radius is 100. And that means that all we have to figure out is the square of 100, so the radius is 10. Okay? Moving on to number 5. What is the area of a circle whose diameter is 8 units? Give your answer in terms of pi and an approximation to the nearest tenth of a square unit, and then show our work. Okay, so the area of a circle that has a diameter of 8. You have to be careful in reading these because you got to make sure that this is area or circumference, and then also you got to remember, is it giving me diameter or is it giving me radius? Very important that you keep those straight because those are very simple little mistakes that kids always make, that grown-ups make, that I make. So be careful. Okay. Blah 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 blah. What is the area? So area, from our handy dandy math reference chart that y'all can use on your STAR test, is pi times the radius squared. Well, this didn't give us the radius, it gave us the diameter. So you got to remember that the radius would have to be 4. Okay? So 4 squared is 16, so the area in terms of pi would be 16 pi. Okay? But it also asked us for approximating it to the nearest tenth of a square unit. So what we have to do is come over here and we're going to say the area is equal to 16 times 3.14. So 3.14 on top because it has less digits times 16. 6 times 4 is 24. 8, 18, 0, 3, 1, 4, 4, 2, 1, 0, 1. And bump the decimal 2 places, 50.24. Now, it says for us to round it to the nearest tenth. So, the tenths place, guys, is this place immediately to the right of that decimal. And because there's a 4 in the hundredths place, then we're going to say that that is 50.2 square units. Okay, so we have this answer in terms of pi, and we have this answer rounded to the tenth place. Okay, number 6. Pi is the ratio of blank of a circle to the blank of the circle. Remember when we drew this? Oops, not when we drew that. When we drew this. Here we go. I told you that circumference is equal to pi times the diameter. Pi is the ratio of the diameter of the circle to its circumference. Did I say that backwards? Pi is the ratio of the circumference. Gotta say the circumference of a circle to the diameter. Because the circumference is 3.14 times the length of its diameter. It has a rational approximation of, this is asking you what's the rational number that represents pi. 3.14. And you will also see it written as 22/7. You don't really have to worry about that 22/7 right now because it hasn't focused on it that much, but you will see that in the future, so didn't want to leave that out. The next lesson, what is the ratio that represents the probability of a simple event occurring? Okay, so you need to remember this. It's the number of favorable outcomes, to the number of possible outcomes. That's my ratio. Okay, the probability that you're going to toss the head on a nickel. Well, if you have a nickel and one side's a head and one side's a tail, one of those is a favorable outcome, but there are two possible outcomes. Okay, roll an even number on a 1 through 6 number cube. Our sample set is 1, 2, 3, 4, 5, and 6. Okay, rolling an even number, there is this one, and this one. Oops. Here our sample set was heads, sample space, sorry, heads and tails. Okay, and we were looking for this one. Now our favorable outcomes are 1, 2, and 3 out of our possible outcomes 6, and you can reduce that to 1 out of 2. Okay, the back side of that, Beatrice tossed a nickel 30 times and she tallied 16 heads and 14 tails. So she's done an experiment, so we're figuring out experimental probability, or we can figure out experimental probability. The experimental probability that the next toss is going to be a tail. So the probability of a tail, in this case she's gotten the favorable outcomes is 14 out of the possible 30. Okay, you can reduce that to 7 over 15 because this divides by 2, divide by 2, and that's as far as we can go. So we're going to say 7/15. The experimental probability of the next toss is going to be a head, so probability of a head, 16 out of 30. Reduce that, we get 8 out of 15. You can't reduce it any further, so that's my probability. Okay, now we're going to do something different. It says theoretical probability. The theory is what it is in theory. Use your sample space. When you're tossing a coin, the possible outcomes are heads and tails, and that's it. So in theory, the probability that you are going to get a head is 1 out of 2. Okay, so when it's asking about the experimental probability, make sure that you use the results of the experiment. This is the experiment. Experiment. Here it's talking about what it is in theory. Okay, 1 out of 2, right? Okay, the next question says for us to make a sample space for tossing a nickel and rolling a number cube. So we know that if it was just the nickel, then it would be heads or tails, but we're also rolling that number cube, so it can be a heads and 1, a heads and 2, a heads and 3, a heads and 4, a heads and 5, a heads and 6, or it could be a tails and 1, a tails and 2, a tails and 3, a tails and 4, a tails and 5, and a tails and 6. Okay, this is my sample space, all of the possible outcomes for those events happening together. How many items are in my sample space? Well, there's 12. the probability of tossing a head and rolling a 4, well, there it is, tossing a head and rolling a 4. That is one favorable outcome out of the 12 possible outcomes. You could also say, use the independent probabilities of those events. Tossing a head would be 1 out of 2. Rolling a 4 would be 1 out of 6 probability. If you multiply those, 1 times 1 is 1, 2 times 6 is 12. Okay. Either ways, okay. The probability of tossing a tail and rolling an even number. Okay, so a tail and an even number, that means we're looking for tails and 2, tails and 4, or tails and 6. Those 3 are favorable outcomes. So 3 out of how many? 12. 3 12s. That reduces, if we divide by 3 and divide by 3, to 1 over 4. Okay? So tossing a tail is 1/2. Rolling an even number is also 1/2. 1/2 times 1/2 is 1/4. Are these events independent events or dependent events? Okay. These are independent events. The outcome of one event does not depend on the other. Okay. Now, moving on. Bag contained 3 white marbles and 3 black marbles. So we've got my little bag, and think of it as a little draw bag, and it's got 3 white marbles and it's got 3 black marbles. Black, black, black. Okay? You draw a marble, you record its color, and you do not put it back before drawing a second marble. We're going to have a dependent event. What is the probability that you will draw a white marble and then a black marble? So this probability is easy. We got 3 out of 6. Okay? So on the second event, though, on the black marble, there are still 3 black marbles, but now there's only 5 marbles in the bag because you took one of them out and you did not put it back. So 3 times 3 is 9, 6 times 5 is 30. Reduce it, and I get 3 tenths. Okay, so that probability is 3 out of 10. The next one, you draw a marble, you record its color, you replace it before drawing a second marble. What's the probability that you're going to draw a white marble and then a black marble? This time you replace it, and that means you put it back. So we have 2 independent events this time. One does not influence the other. We don't have to change our total possible outcomes. Okay, so drawing a white marble would be 3 out of 6. Drawing a black marble would also be 3 out of 6. So that gives me 9 out of 36. Reduce it. Oops, I'm going to divide by 9 now. And I get 1/4. Okay. Did you get it right? I hope so, because remember, you're not supposed to be doing this with me. You're just checking your work. Alright, lesson 5. A triangular prism and a triangular pyramid have congruent bases and heights. It's important to know, because that lets you know that they have that relationship. What is it? Okay, the volume of the prism is 183 cubic units. What's the volume of the pyramid? You'll remember that we always said that if it has a congruent base and the same height, that means that the prism is 3 times the volume of the prism, the volume of the pyramid. Okay, so if the volume of a prism is 3 times the volume of a pyramid, then if we take the volume of this prism and we put it on top, then that will give you the volume of the pyramid, x. So 3x equals 183. That means that all you got to do is divide 183 by 3, and some of y'all went straight there, and that's okay. And you got 61 cubic units. Okay. Hope you got it right. If you didn't show your work on that one, make sure and show this. Sometimes you know how to do it, but it's hard to show your work. I'm helping you out. That's how you reasoned it out. Okay, number 2, a triangular prism and triangular pyramid have congruent bases and heights. The prism's triangular base has a height of 14 centimeters and a base of 9 centimeters. It has a volume of 504 cubic centimeters. What's the volume and height of the pyramid? So we're going to have to figure this out. We've got a prism that has a triangular base, okay, and its height is 14 and its base is 9, okay, and it is a prism. So let's go ahead and draw the prism. Okay, so we made the prism, and this whole thing has a volume of 504 cubic centimeters. Okay, and the question is, what's the volume and height of the pyramid? So we know that the height is the distance, the height of a pyramid, or the height of a prism, is the distance between its bases. So this is going to be the same as the height of that pyramid. Okay, so we are going to figure out what the area of the base is, and the area of a triangle is the base of the triangle times the height of the triangle divided by 2. So the base of the triangle is 9, the height of the triangle is 14, divide that by 2. Well, 14 divided by 2 is 7, and 7 times 9 is 63. So 63 is my capital B, the area of the base. Okay, so if the volume is equal to the area of the base times the height of a prism, then I can put 504 into the volume, just substitute that in. We've already figured out the area of the base, which is 63. And we're going to plug that in, times the height. Well, this is an algebraic equation. We can solve for h by dividing both sides by, you got it, 63. So, those cancel, and the height is equal to 504 divided by 63. Okay, I don't know what that is. Do y'all know what that is? Somebody give me a calculator. Goodness. Nope. I'm going to do this. 504 divided by 63. Well, 63 times 10 would be 630. And I'm going to say 8, because 8 times 3 is 24, and that ends with a 4. Let's see if that works. 8 times 6 is 48, plus 2 is 50. Oh, right off the bat, we got it. Okay, so that means that H equals 8. Equals 8. And that means we figured out, so far, the height of the pyramid. The height of the pyramid is 8. The volume of the pyramid is 1/3 of 504. It is 1/3 of the volume of the prism. Because of that ratio, if they have the same base and the same height, that means the volume of the pyramid is 1/3. 6 times 3, 18, 24. 3 goes into 24 8 times. So the volume of that pyramid would be 168 cubic centimeters. And this would be a linear measurement of just 8 centimeters. So here we go, guys. We have solved the problem. Okay. Number 3. Did you get that right? I hope you got that right on your paper. A triangular prism has a volume of 378 cubic units. That is the prism. The height of that prism is 18. What's the area of the base of the prism? Okay. So again, we're going to start with the volume of a prism formula, which is the volume is equal to the area of the base, which is what we're looking for this time, times the height. So let's color coordinate this. The volume is 378, so volume is 378. Area of the base is x. That's my unknown. Okay, and the height of the prism is 18. So height is 18. Okay, again, we have this algebraic equation. We want to solve for x. So to get x by itself, I'm going to divide both sides by 18. Boom, boom. X is equal to 378 divided by 18, and that will be our answer. 378 divided by 18. 18 times 2 is 36. Subtract and get 1. Bring down 1. 0. Oh. I believe that the area of the base is 21 square units, because if we substituted it in, 21 times 18 is 378. That is my area of the base. Good job. Pat yourself on the back if you got that correctly. If you didn't, that's okay. Let's try on the next one. Lesson 6. Okay, tells us to create a composite figure using a rectangle, a square, and a right triangle, and label our dimensions. Okay, so this is a square, 3 by 3. A right triangle, 3 by 3. And a rectangle, 1 by 3. Well, find the area of my figure. Okay. Well, the area of this is 3, the area of this is 9, and the area of this 3 times 3 divided by 2 is 4.5. I could have found some friendlier numbers so I didn't have to have a decimal, but oh well, it's still not hard. We can find the area of our figure by adding that together, 9 plus 3 plus 4.5, and that gives me 16.5, and we'll just call it square because it is area units. Okay, this is from the imagination of Miss Page. Whatever is on your paper ought to be different than what's on my paper, because hopefully you don't think the same as me, because that would be scary. Okay. Moving on, number 2, it wants us to find the area of this composite figure. So first of all, we're going to start off with step 1 of finding the area of composite figures, which is to identify the shapes that make it up. So we've got this right here, which is a parallelogram. We know that because it's got these little arrows here that are pointing in the same direction, showing us that they're parallel. So the formula for the area of a parallelogram is base times height, just like a rectangle. And then I'm going to put parallelogram. And then the second shape is this here triangle. Okay, so the formula for the area of a triangle is area is equal to the base times the height divided by 2. Okay, let's fill in what we've got. We've got the base of this parallelogram is 20.8. So substitute that in, 20.8. The height of the parallelogram is the distance between its two bases, which is 12. So if you multiply that, you'll get the area of the parallelogram. Let's come over here and fill in my numbers for the triangle. The base of the triangle is 30. The height of the triangle is 14. We got to divide that by 2. Well, this one I can do with mental math. 14 divided by 2 is 7. 7 times 3 is 21 plus 0, or not plus 0, but with a 0 in front, is 210 square units. Okay, so that's for the triangle. Now going back to that parallelogram and doing the multiplication. I avoided it as long as I can. So bump the decimal over one place. So the area of that parallelogram is 249.6 square units. And if we add those two together, that's the last step of finding the area of a composite figure. We're going to add those two together. So 249.6 plus 210 gives me 459.6 square units. And that, my friends, not my friends, y'all are my students, I'm so sorry, that's me, 459.6. Okay. I'm going to do one more, and then I'm going to take a break and do the rest of them later. So, the last one for now, for Miss Page. Find the area of the composite figure below. Step 1. My pieces are a square right here. Okay. My parallelogram. Parallelogram. And right here, choop choop, is my quota circle. Alright. Step 2. Write my formulas. Formula for a square is base times height, side squared, length times width. Any of those will work. For the parallelogram, same thing, base times height. For the quarter circle, this is where things get interesting. We got to write the formula for the area of a circle, which is pi r squared. And because it's 1/4 of a circle, we got to divide it by 4. Okay? Alright guys, let's plug and chug, plug and chug, plug and chug. 18 times 18. I think it's 296 off the top of my head. Let me make sure. 8 times 8 is 64. 8 times 1 plus 6. Apparently I was wrong. Here we go. 4, 2, 1, 324. What was I thinking? Okay, so that's the area of that. Area of parallelogram. The base of this parallelogram is 18. The height of this parallelogram, the distance between my two bases is 15. And come out here and multiply. Can't do the mental math anymore. Can't even depend on it. I messed up. Oh my goodness. 270. Okay. Quarter circle. Now things get interesting. We got to use 3.14. Oh man. Okay. So this is a square, and that means that all the sides are the same. We've got these little tick marks that show that. So that means that the radius of the circle is 18. So I got to do blah blah blah. 18 squared, which I know is 324. So 324 times pi divided by 4. And if I say 324 divided by 4, that goes 81 times? Yeah. Because 32 divided by 4 is 8, and then 4 divided by 4 is 1, 81. It works. So 81 pi. We're going to find the actual value of that, and instead of just leaving it in terms of pi, we're going to multiply it times 3.14 times 81. 3140 32 24 25 4 3 4 2 5 bump bump. Okay, 254.34. And then the last step, step 3, is to add up all of the areas. So when I add them all up, I've got 324 plus 270 plus 254.34. Oop, where'd that 5 come from? I don't even know. And I know that I get 0.34. And 4 plus 0 plus 4 is 8. And 5 plus 7 plus 2 is 14. So carry the 1. 3 plus 2 is 5. Plus 3 is 8. So 848.34 square units. No, inches. Don't forget your units, children. And I'm going to box that up because we are through, or I am through for now. We'll pick up with lesson 7 on the next video.